Hello students, in this video we'll discuss Chebyshev's differential equation and the orthogonality of the Chebyshev polynomials. Let's recall that Tn of x, Tn of cosine of x is the cosine of nx, defines the nth Chebyshev polynomial, defines the nth Chebyshev polynomial. And so in particular, we can do the inverse cosine and figure out that Tn of x is the cosine of n cosine inverse of x, right? And so I want to see what differential equation this family of polynomials satisfies. So I'm going to first differentiate it once. So Tn prime of x is going to be negative sine of n cosine inverse of x, and then times negative n over the square root of 1 minus x squared, because that's the derivative of inverse cosine. The derivative of inverse cosine is negative 1 over 1 minus x squared, and then the n from the chain rule, okay? And so if I simplify this, this becomes n times the sine, n over square root 1 minus x squared, sine of n cosine inverse of x, like that. That's the first derivative. Now let's do the second derivative. So the second derivative is going to be what? So Tn double prime of x is going to be n over the square root of 1 minus x squared times the derivative of sine, which is cosine of n cosine inverse of x, and then times the derivative of the inside function. So it's the derivative of the inside function now. The derivative of the inside function is going to be a negative n times negative n over the square root of 1 minus x squared. And then we have to multiply by the derivative of this thing over here, right? So that's going to be a plus n sine of n cosine inverse of x. And then this function over here is really, this is really 1 minus x squared to the negative 1/2 power, right? So I'm going to do the derivative of this, I'm going to get a negative 1/2, do the derivative, get a negative 1/2, 1 minus x squared to the now we're in the denominator, so it's going to be negative 3/2 power, like so, and then times negative 2x, right? Negative 2x. And so, of course, the 2 and 1/2 cancel out, and so you can get an x over what? You're going to get an x over, and we have an x over what? We have an x over 1 minus x squared to the 3/2 power, like that, okay? And so now here's the key observation to make in all this over here. If we look at this expression over here, and if we look at this expression over here, and if I now notice that I have a 1 over the square root of 1 minus x squared, and I have the same thing over here. So what I'm going to do now is I'm going to multiply Tn double prime by 1 minus x squared, 1 minus x squared, okay? So in other words, 1 minus x squared Tn double prime of x is going to be equal to what? Is going to be equal to this expression over here, which is negative n squared, because now the squareds cancel out, so that's negative n squared. And then look what we have. We have cosine of n cosine inverse of nx. That's exactly the nth Chebyshev polynomial. So that's Tn of x, okay? And now what's this term over here? So now this term over here, I'm going to have a what? I'm going to have an x, and then I'm going to have an n sine over the square root of this thing over here. So that expression is exactly equal to x times the first derivative. So then we have an plus x times Tn of x prime over there. So just identify what we've seen from the differential equations, and now we arrive at Chebyshev's differential equation. So Chebyshev's differential equation is the following. It's 1 minus x squared Tn double prime, then minus x Tn prime, and then plus n squared Tn is equal to 0. So that's Chebyshev's differential equation. So this is the Chebyshev ODE. Okay, beautiful. And now an interesting consequence, and this follows from the general Sturm-Liouville theory of ODEs, is I get orthogonality between two of these different things if I have the right choice of weight. So here's what we're going to do. We're going to consider the following. Let's consider, so I claim, the claim is that if we integrate from negative 1 to 1, Tn of x times Tm of x with respect to the weight 1 over 1 minus x squared, I will get 0 if n is not equal to m, right? And of course, it's an excellent exercise in trig substitutions to figure out the values are going to be when m and n are equal to each other, right? So for example, when m and n are both equal to 0, we can actually trivially do this. When m and n are both equal to 0, then what we're going to have is we're going to have something that looks like an arc sine. And when two of them are exactly the same over here, we'll be able to just change the variables immediately and get what we want. So let's prove this orthogonality first, though. Okay, so let's claim this is true. All right, so now what we're going to do to prove that claim is the following. So we're going to look at the function wn. So let's assume, we're going to assume this condition is true. I'm going to look at w, which is going to be w of x, which is tn prime of x, tm of x, and then minus tm prime of x, tn of x, like so. Okay, so I'm going to consider that function w. Now here, of course, I'm assuming that n is not equal to m. And so let's look at w prime. So what's w prime going to be? So w prime of x, now I'm going to suppress the x from this calculation. It's going to be tn double prime, tn double prime, tm. Then it's going to be a term that has tn prime, tm prime. And I'm going to not even write that term because I want to do the derivative of this expression. We have a minus tm prime, tn prime, right? So those are going to cancel out. And so all that we have left is going to be this thing over here. It's going to be tm double prime, tn, like that, okay? And now the key is to multiply this. Let's consider this expression over here. Let's consider w, this 1 minus x squared w of x, like that. And then minus x w of x. Let's put prime over here, okay? So what will this expression be? This expression over here is going to be, let's do it carefully. We're going to have a tn double prime tm times 1 minus x squared. And then we're going to have a minus 1 minus x squared tm double prime tn. Okay, that's the first two terms over there. Then I'm going to have a minus x tn prime tm, and then a plus x tm, and then just a single prime over there, right? So that's a tn prime, good, and then a tm prime tn, like so, okay? Excellent. And so now what's the idea? So if we look carefully at this, we can see over here that, look at this term over here. So I have a tn double prime times 1 minus x squared, and then this term over here I have a minus x tn prime times tm. So both those terms that I've just highlighted have what? Have a tm in common, and I have a tn double prime times 1 minus x squared and the tn prime times x. So those two highlighted terms are going to give us what? By the definition, they're going to give us a negative, so that will be equal to n squared tn, right? So in other words, I can add it in that over there and I'll get 0, right? So we're going to have, for those two terms are going to subtract and give me an n squared with a negative, so I'm going to have a negative n squared tn, like that. Great. Okay? Because I know that 1 minus x squared tn double prime minus x tn prime is equal to negative n squared tn. So those two terms over there, and I have a tm, of course, right? So tm, like that. Tm and a tn. And now look at these terms over here. If I pull out a negative sign from them, what will we get? If I pull a negative sign out from those terms over there, I will have a m with a positive sign plus m squared tn tm, like that. And so altogether, this gives me an m squared minus n squared, which is non-zero, tn tm, okay? And so now the idea is to integrate. If I integrate m squared minus n squared times the integral from -1 to 1 of tn of x times tm of x times dx over the square root of 1 minus x squared, well, what is that equal to over here? Well, in other words, this expression over here is exactly equal to this expression right there, right? So this will be equal to this m squared minus n squared integral from -1 to 1. And then what will happen over there, this 1 minus x squared will hit that square root of 1 minus x squared and give me just a square root of 1 minus x squared times w prime of x. And then this will be a what? A negative x over the square root of 1 minus x squared times w of x dx, okay? And now the beautiful thing, and some parentheses over here, the beautiful thing is that this expression inside the parentheses is a perfect derivative. It's the derivative of the function 1 minus the square root, 1 minus x squared square rooted times w prime, right? So this thing over here is nothing more than just the derivative with respect to x of the square root of 1 minus x squared times w of x. We can just check that immediately, right? Because if I do the first derivative over here, I'll get this term over here. Then the derivative of the square root of 1 minus the square root of 1 minus x squared is exactly equal to 1 over the square root of 1 minus x squared times 2 times negative 2x, which gives me this expression over here. Excellent. Okay. And so now, what do we have? And so now, since this is a perfect derivative, we can just actually evaluate this. This is going to be this function over here, square root. And then I have one sign error over here, so it's my sign error. So I think everything should be working out just fine like this. That works out. And that's good, okay? And so then we have what? This is going to be the square root of 1 minus x squared, w of x, from -1 to 1. But when I plug in -1 and 1 to this expression over here, we get 0. So in other words, if m is not equal to n, then I have that these functions tm and tn are going to be perpendicular with respect to the weight 1 over the square root of 1 minus x squared. Thank you very much.